Okay guys, we're going to look at our properties of logarithms, okay, and you can find this information starting from page 165 in your notes, okay. So logs have some special properties, just like we saw with exponents. There are some different tricks and patterns that we can use with logs to help us solve equations and adjust and kind of manipulate some expressions. Okay, so the first box you're going to see is going to be the box labeled change of base formula. Okay, and this is a little bit outdated because modern calculators kind of have built in the change of base, so they can kind of do it all in one, but it's still a pretty useful skill and it comes up on occasion. So the idea is basically that we can rewrite any log with a different base by just setting it up as a fraction, okay? And the key thing to remember is the number inside, so for example on problem 1, that 25 will end up in the log that's on top. And the 4 would end up as the log on bottom, okay? And so most commonly your calculators used to work in two different modes, which was base 10, okay, or natural log, which is base e, okay? Now remember, e is just a constant, not any kind of variable, just a constant, okay? So if I was rewriting this original problem as either base 10 or base e, okay, we could write this as log of 25, right? Log base 10 of 25 over log of 4, okay? And this would be the same thing as me saying natural log of 25 over natural log of 4, okay? So all three of these are equal, okay? And if you needed to put it in a calculator to find the value approximate of this, you would get that this is approximately 2.322, okay? So again, not all calculators, especially if you go back a few years, will accept log 4 of 25. The modern TI Inspires definitely do, but by using this change of base, we can turn things into either base 10 or base E, and that will let us solve it. So if you typed in any of these expressions, you should get the same number. Go ahead, take a second and try it out and make sure that you do as well. Okay, so if you look at the next box, you'll see three different properties in there: product, quotient, and power property. Okay, these reference some other ways we can manipulate logs, and they are actually based on the same rules that we've seen from exponents, except they are now a little bit backwards because, of course, the logarithm is the opposite of the exponential. Okay, let's go through these properties real quick and then put them into action. So the first property we mentioned is the product property. And what it says is if you have two numbers multiplied together, you can split up the log into two logs being added together, right? So a product ends up becoming a sum, okay? And of course, if multiplying is going to lead us to addition, division, which gives us the quotient, is going to lead us to subtraction instead, okay? So two things being divided in your log can instead be subtracted. So if you ever see two logs added together, you can multiply. If you ever see two logs subtracted, you can make them a fraction or a division, okay? And of course, our final property is going to be the power property. And the easiest way to think about this is that an exponent that is out in front will drop in front of the log and become a coefficient or a multiplier on that, okay? So we'll see some of these put into action, but you can refer back to this box to see kind of the general formula for it. All right, as we work through this exercise, be sure to refer back to the log rules and try to match up the patterns so that you can apply these to other problems as well, okay? So the goal in this first section is to turn things into natural log of 2 and natural log of 3, okay? So the first one they said is natural log of 6, and 6 is obviously neither 2 nor 3. But can we rewrite 6 maybe in terms of 2 and 3 Well, we absolutely can do that, right? The natural log of 6, well, 6 is just 2 times 3. So isn't that the natural log of 2 times 3? And I'm going to put parentheses to show you that all of that is inside of that natural log. Now, you see that these are both multiplied together, which means maybe we can put that product property into use. So remember, what does a product become? Hopefully you got that it actually becomes a sum of 2 logs. So I'm going to turn natural log of 2 times 3 into natural log of 2 plus natural log of 3. And then I can say, hey, is my problem in terms of natural log 2 and natural log 3? Sure is. I see those are the only terms I have left. So I'm going to go ahead and box that off as my answer. Okay. So we've completed problem 3 and seen how we can make things in terms of natural logs 2s and 3s. So let's see if we can do the same thing with 4. Okay, so if you have any ideas about what the first step is, go ahead and try the first step and then see if I'm going to do the same thing. The first thing I noticed with problem 4 is that we have a division or a fraction. And I know I can turn that into a subtraction statement instead. So I can have natural log of 2 minus natural log of 27. Now, the big question lies, how do we turn this 27 into either 2s or 3s? Now, hopefully some of you recognize that 27 is actually 3 cubed. So let's rewrite this. Natural log of 2 minus natural log of 3 cubed. And let's just make a note here. 27 is 3 cubed. All right. Now, sure, this is getting kind of closer to what we want, that everything is only natural logs of 2 and 3. But how do I get rid of this exponent? Is there a rule that can help me with that? So if we look at the power rule, you'll see that, hey, exponents out in front can be dropped out in front as a coefficient instead. So now I've got natural log of 2 minus 3 natural log of 3. And now I see that everything is in terms of natural logs of 2 and 3. And you could, if you wanted to, plug this in your calculator at any of these steps, right, in the blue or in the green as our final answer. And you should get the exact same number every time, showing that, hey, I am moving stuff around and manipulating the expression, but not changing the value, and I've followed all the correct algebra rules. Let's see if we can apply some of these log rules to finding exact values, which will help us really solve equations that have logs a little bit further in the future. Okay, so I'm going to start with number 5 here, which is log 5 of the cube root of 5. And in order to solve this, the first thing I'm going to do is I'm going to take this cube root and we're going to rewrite it as an exponent because it's a lot easier to work with in that sense. So the cube root ends up becoming to the 1/3 power. Okay, notice I kept the bases the same and everything else the same. I just turned the cube root into a 1/3. And now you may remember from the very last problem I did that an exponent up here can be moved down in front as a coefficient. So now I might have 1/3 log 5 of 5. And this piece, log 5 of 5, is going to be equal to 1. Okay, and I can bring my 1/3 down. So my final answer for this will end up being 1/3. Now, this may seem a little odd at first, but if you remember that the log of any base of itself is going to end up being 1, right? So if you have log b of b, that will always equal 1. So if it's natural log of e, if it's log 10 of 10, log 2 of 2, log 16 of 16, you will always get 1. And that will help you continue to break this down and get to our final value. Let's see if we can find the exact value of the second expression. If you're feeling confident, go ahead and try it yourself. I'll give you a hint though. There's more than one way to do this. So if you find your way to the correct answer and you see that I did it differently, that's okay, as long as you followed all the rules. All right, so when I saw this, I saw 6 natural log of e to the 6th minus natural log e squared. And what jumped out at me was that both of these were already in terms of e, and that I could just bring these down in front. Okay, so I could have had 6 natural log of e minus 2 natural log of e. And of course, the natural log of e, this is just going to be equal to 1, because remember, natural log means base of 1. So I can rewrite this as 6 times 1 minus 2 times 1, or 6 minus 2, and just get 4 as my answer. Now, what if you decided to do this differently? Could there be an alternative method to solving this question? Absolutely. Look at this. If instead you took problem 6, the same problem, natural log of e to the 6th minus natural log of e squared, and you said, wait a minute, I see that these two logs are being subtracted, and I'm going to make that into a single log, natural log of e to the 6th over e squared. Well, what's e to the 6th over e squared? Remember your exponent rules. These are just going to subtract, and we will get, this is natural log of e to the 4th. Wait a minute. This is starting to look pretty familiar. I can take the exponent, drop it out in front, and I'm going to get 4 natural log of e, which is just 4 times 1, or just 4. So you can see, wait a minute, look, these are the same answer either way, whether I decided to make it a division problem and then break the exponent down that way, or whether I decided to bring my exponents out in front and then subtract them that way. I ended up with the exact same number. So showing you that there are a few different approaches to it, as long as you follow the rules, you can't really go wrong. Okay, our next set of practice talks about expanding logarithms, and basically what they want is they want you to write it as separated out as possible. Okay, so a couple of tips for this means the most number of logarithms, right? So separate any multiplication or division, right? And you'll bring down any exponents as coefficients. After you've done these two things, pretty much you'll be expanded all the way out. Okay, so let's start with number 7 as our example here. So we've got log 4 of 5x cubed times y. Okay, and I'm going to start by breaking the 3 pieces I see into individual logs. So I see 5 times x cubed times y. So here we go, we're going to break it up. Log 4 of 5 plus log 4 of x cubed plus log of y, 4 of y, sorry. And now from here, let's see if we can expand further. Well, I do see an exponent up here. Let's bring that down in front, and that should be the last of what we're doing. So bringing this guy out in front as a coefficient. Log 4 of 5 plus 3 log 4 of x plus log of 4 of y. And there you go, we are expanded. Okay, so again, when we expand, you want to separate all your pieces into separate logs, right? So all the multiplied pieces and all the divided pieces should become their own logs. And you want to bring all your exponents down out in front as coefficients. Let's try another expanding question. So let's take a look at number 8. If you feel like you've got an idea of where to start, go ahead and see how far you can get. Number 8 says natural log of square root 3x minus 5 over 7. Now the first thing I see is the division, so I'm going to break this up into 2 logs. natural log of root 3x minus 5 minus natural log of 7. Okay, now it's a subtraction problem because I split the division up. Now the next thing I see is this square root, and square roots we know are actually fractional exponents. So I'm going to turn this into a fractional exponent first and then go from there. So natural log 3x minus 5, and we'll put that 1/2 power in parentheses. Okay, so make sure that we catch the whole thing, and let's bring the rest of our problem down. So natural log of 7 is being subtracted from here, minus natural log 7. And I see this exponent. Let's drop that down in front as a coefficient as well. So here we go, 1/2 natural log 3x minus 5. And I'm leaving this parentheses because I really do want to show that all of that is in the log. It's very good for clarity's sake. And natural log of 7. So here is my expanded form, right? So I've broken up my log into separate pieces, into separate logs, and then dropped all my exponents out in front. Guys, take a second and attempt problem 9 on your own, and then you can check your work against what I have as the expanded form. So here you can see I wrote out my expanded form. Now, in this case, it's a little odd because we have this 1/2 power that became a coefficient, and it's outside of the whole thing, and technically I could distribute it in if we wanted to. And you could absolutely do that and have the correct answer as well, but I think this is the cleanest way to get to the most expanded form. Okay, so now our next section talks about condensing logs, and hopefully you can guess condensing is the opposite of expanding, right? So we want to kind of tightly pack everything together, maybe make everything into one log if we possibly can. Okay, so we'll just start with number 10 as our example. And you see 1/2 log of x plus 3 log of x plus 1. Well, let's just start by moving the coefficients that are out in front and moving them up into exponents. So I've got log of x to the 1/2 plus log of x plus 1 to the 3rd power cubed. And now we can rewrite these as a product together. So we have log x to the 1/2 times x plus 1 to the 3rd. And again, I keep putting these parentheses because I really do want to keep clear, hey, these are in the log and what's outside of the log. Okay, now we can kind of leave this as the condensed form, or we could turn that 1/2 into a square root if we wanted to, and leave it looking a little bit like this. And there's no need to get fancy with it. It's your choice if you want to go ahead and make those fractional exponents into roots, but just be very careful that you show clearly what's inside the root and what's not. If you feel comfortable with some of these ideas, go ahead and give number 11 a try and see how your answer looks before you look at my work. Okay. So number 11, I see 2 natural log of x plus 2 and minus the natural log of x. Okay, and so here I'm going to put this 2 up as an exponent first. So I've got natural log of x plus 2 squared minus natural log of x. Okay, you see that there's a subtraction happening here, so that is going to make us divide. And the easy way to remember this, guys, everything that is subtracted, everything that is like a negative term is going to end up at the bottom of your fraction. Okay, so natural log of x plus 2 squared over x is going to be my combined form. And this looks condensed, so we'll just go ahead and put that as our final answer. For number 12, I would actually start by working out everything in the parentheses and then dealing with that 1/3 way out in front. Okay, so these square bracket parentheses, we're going to start from there first, and then we'll go from there. So this is problem 12. And we've got 1/3 log 2 of x plus log 2 of x plus 1. And let's see how this combines together. So first, I see this plus, right? So that means these are going to multiply together. So we've got log 2 x times x plus 1. And I'm going to put big parentheses around this because I really do want to keep track of that being inside of there. And in front of this, of course, is my 1/3 that was right here. Okay. And what am I saying? This whole piece inside of the green is right there. All right. Now, how can we continue this problem now? Okay. Well, this 1/3 is, of course, going to be an exponent. So let's turn that into a exponent here. We've got log 2 of x times x plus 1 to the 1/3 power. Okay. Now, couple of ways we could write this. Okay. One of them, we could leave it the way it is. We could also write this as maybe log 2 of the cube root of x times x plus 1, okay? Showing that, hey, we put everything inside of that root. Or even one other way we could write this is by distributing the 1/3 in, okay? So maybe we have log 2 of x to the 1/3 times x plus 1 to the 1/3, okay? So some different things, but all of these are valid. Probably the easiest place to stop is just right here, okay? And you don't have to go any further than that. But if you want to make sure that, hey, I want to show that I put everything in the right place and not have to worry about these parentheses, that second piece right here, where we've made it into a root, is a very good way to write it. Now, I'm hoping you feel pretty comfortable with all the condensing and expanding. Go ahead and take a second and try out number 13. This one's a little bit challenging because there's a lot of pieces, but overall you can use the same methods that we've used earlier. And then you can check your work against what I've come up with for my answer. So here you can see my answer. I put two versions of the final answer in white. Okay. Notice how I've distributed things out. One good habit to be in is, of course, putting big parentheses around what's in our log. All right. That is kind of helpful in the sense that it lets us keep track of what's in the log, because you never want to think, wait a minute, is that +5 in the log or is it outside of the log function? So I hope this video was helpful in using some of these log properties and getting them in your head. Okay, we will keep doing more with this, and we'll use these same properties to solve equations and simplify more of these log expressions in the future. Okay, there are a few more condensing problems. You can find them in your book. Make sure that you practice with this because you really do need to be familiar with these log rules so that you can solve equations using logs. As always, guys, I hope you found this video helpful and happy studying.